All right, 9.7, inscribed angles. We've been talking about inscribed angles for a little while now. We're going to go a little bit deeper into our knowledge of them. Okay, so an inscribed angle is equal to half the measure of the intercepted arc. So, we have BAC, okay? Angle BAC is inscribed. And notice the important thing is the vertex is on the circle, or the circle edge, if you want to think about it. Okay? That's the difference between that and a central angle. So there's a BAC or CAB. So find the measure of angle 1 if BC is 70. So if this was 70, backwards. If the measure of BC is 70 degrees, remember not the arc length, but the measure, 70 degrees, that makes this 35. Now remember, if we actually had the central angle right here, you don't have to draw this, but just to remind you, it would look like this. That would be 70 degrees. So the central angle matches. So that would be 35. If BC was 84, again, you just divide by 2, multiply by 1/2, and that would be 42 degrees. 280, well, 280, half of that, 140 degrees. Now, of course, that would be correct if the A wasn't here. But this isn't BC, so I made a mistake there. That's my bad. BAC is this major arc. I didn't pay attention. 3 letters, major arc. So therefore, if that's 280, we have to do 360 minus 280, which leads this to being 80. So now the actual answer to this is half of 80, which is 40. Now we're going the opposite direction. Find BC if this is 40. Well, we're just going the opposite direction. If this is 40, then that would be 80. And if 1 was 36, this would be 72. Are congruent. Okay? So I'm going to do these in 2 different colors. Here's angle 1. Here's inscribed angle 2. And notice, I lied, I'm going to use 3 colors. This is the same arc. Well, since the arc is the same, then they must both be the same. Now, it says if AB is 120, okay, and if it helps, just come on here and just put one of them. Okay, and just think about them separately if it helps. So, just like the previous page, if AB is 120, then angle 1 is half of that, 60. And again, you come over here and you put 2 and you put AB, and that's 120, and that would be 60. That's why they're the same. That's why they're congruent. So if it helps you separate them into 2 different drawings, go for it until you understand it well. Okay, find the measure of angle T. Okay, well, once again, it might help if you use some colored pencils, something like that, to show what's happening here. They are both intercepting the same arc, SV. So therefore, we know that 3x minus 5 is equal to x plus 15. So we just subtract x, we get 2x, add 5 to both sides, we get 20. Divide by 2, x is 10. That's not what it asked though. It didn't say solve for x, it said solve measure of angle t. So we're going to plug this 10 in right here. 3 times 10 plus 5. Sorry, minus 5. That makes much more sense with where we're going. Minus 5. Well, 3 times 10 is 30. Minus 5 is 25. So there's the answer. Angle T, the measure of angle T is 25 degrees. Well, let's check. If we plop a 10 over here, what do we get? 25 degrees. And that makes sense because they should be equal. And they are. Okay, an inscribed angle in a semicircle is 90 degrees or a right angle. Okay, so once again, here is your inscribed angle. The arc that it's intercepting is right here with a measure of 180. Half of 180 is 90. That's why it works out. Okay, find the values of x, y, and z. Well, if you look right here, here's an inscribed angle. That's for z. If this is 43, that is half of whatever z is. So that makes this 86 degrees. So we have z. All right, now let's go for y. We know we have here a semicircle. And we know this piece right here is 110. So we got to think about what that leaves us here. Well, 180 minus 110 is 70. And if that is 70, then angle 1 is also 70, because remember, y is a central angle at the center, O. So those match up. Now, if you look here, a lot of colors going on. Here is another inscribed angle with 70 right here, which makes x 35, half of the 70. So like I said, on a problem like this, if it helps you, if you're trying to find z, put the 43 here and solve for z. And if you need to, once you find that this was 70, it's not a big deal to separate them out so you can see them better. Everybody has their own skills. Sometimes it can be confusing when it's overlapping. Do what is best for you. Okay, opposite angles of a quadrilateral inscribed in a circle are supplemental. All right, so opposite angles in quadrilateral. That means this angle and this angle are opposite of each other. Okay, like so. So since opposite angles are supplemental, for y is going to be equal to 180 minus the 68, which means y is 112 degrees. Okay? Now, if you look at the 160 here, this arc, it comes from this inscribed angle here. So the x and the 160 are tied together. Remember the rule we just learned that for an inscribed angle, it's half of the intercepted arc. So for x is half of 160, So x is 80 degrees. Now, if you look here, what we have is a triangle with 68 here and 80 here. Okay? We're going to use the idea that 180 degrees are in a triangle, which leaves 32 up here. 32 degrees. Now, again, we have a lot of color here, so get rid of some of this. That's not what I wanted to do. Alright? So, we now know 32 degrees is this angle right here, leading to this arc, which is z. So z is going to be 2 times